Hello, I'm Daryl Coyne. I'm president of Stats Club. I'm here to give you a brief tutorial on SQL. We're centering more along the lines of data analysis, so like using select statements, not how to actually create the database. And it is created, it is crafted. I would emphasize respecting the database, especially since if you destroy a database, you basically destroy a company or whatever. So, yeah. So, this concept of what I'm going over to the talk. So, basically, what is SQL? So, that actually should be statements there instead of clauses. Are the data types in SQL? Brief understanding of like what constraints are, what the filter clauses are, like where, having, grouping and aggregate functions, group by clause basically, how to join up the various different tables, subqueries. Bit on functions. Unfortunately, functions is too big of a topic to actually squeeze down into really almost any length of time, so I just basically give an idea of what functions are, and using SQL within our. First of all, SQL is a relational database, which is basically tables containing rows related to each other in tables. For instance, primary keys basically specify that each row is unique, and foreign keys basically reference primary keys to help in joining tables. Foreign keys are basically is a subset of keys. The entries is considered same thing as rows, attributes, very similar to columns. To give you an idea of what a database looks like, I made this up for Stats Club. For instance, Stats Club here. Members, which more you guys you should read. Yeah, members attend events, and so this is attendance for events, and each one within an event there's a type: social, educational, presenter. For me, that's his organizer. Me here again too. Poster was Abby, and start time, end time, location, budget. Each event has an expense related to it, which related to the event, and also expense. Each organizer is basically a member of the exec, and which has positions, and positions have descriptions.
Why do you have two lines going to exec? From event to exec?
Because organizer and poster, those are two different things, but each one is different. So that relates to the quest ID for exec. So that's just to get an understanding of it. The dashed lines are foreign keys. The straight lines are primary keys. Key could be a tuple of columns. So, like for attendance, there's event and student number, which, like if we fill up everybody here with for in the table, like be SQL tutorial and then whole list of numbers for that. So, like the SQL tutorial and then a number, SQL tutorial number, and for each one's different. That ensures unique for attendance. And that's basically how that goes. Everyone understand that? Okay. This just basically gives an understanding of what the databases look like. So SQL is a non-procedural language, meaning that the execution of each clause is not determined by the writing it out. It's determined by like the implementation of SQL rather but not the programmer itself. So you can't say, okay, execute this clause at this time and run this code. You're just basically telling it what you need done, and sends it to the optimizer to do it up. It's made up a bit of sub-languages: data manipulation language, which basically select, which makes queries, and insert, update, deleting statements, modify the instance of a table, data definition, which basically creates, drops, or alters a database, data control, basically grant or revoke permissions from a user. For this purpose of this talk, SQL commands are all in uppercase. However, SQL in general is not case sensitive, so for generic purposes, I will use this here to basically specify, okay, put in a table, variable, data type, anything you want here. This basically just tells you what you need inserted into it. Display is basically so that I can make a generic definition, and then I'll give an example of what it is. And so you won't actually be, in the actual code, you won't be actually seeing these brackets. And same thing with the square brackets. Square brackets just basically for optional arguments. And I'll call dot 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 is just meaning additional code. A statement ends with a semicolon. This basically tells it that execute from here. So it basically reads it all and then sends it to the optimizer, and then that executes the code. SQL is data independent, so you could have various different ways of implementing it. Like you could have objects, you could have actual objects in a table, or some other formatting, and yeah, SQL wouldn't matter. The programming of SQL would not matter. It would be up to the database engineer to actually create the interface to implement those changes or get that data. The uses of a new line is only for readability purposes. You don't really need it. It ignores the SQL ignores the new line statement. Same thing with white space, other than just delimiting it. That there is backslash star is for programming comments. That way, if you're actually writing up code, that's how you would show up comments in SQL. Give an example. This is all the execs from Stats Club. He's the one that usually does up posters. That's me here, president, and also occasional presenter. Our secretary, vice president, another events guy, Jamie, and Simon, treasurer, which also got us our food. So give him a clap for that, though. I don't think he's here, but yeah. Hopefully he sees us later on. So. Some definitions: entities, basically something of interest, an account, a personal account, row. This usually relates to a row. A column is, or attribute or field is a piece of data stored in the table. Record is row or record is a tuple of columns. A table is a collection of rows or records. There's persistent saved data, tables saved in to your hard drive, into the database. But that table generically is referred to a various different collection of stuff. Like it's referred to as a result set, which is a non-persistent table taken back from a query, like a select statement. A subquery is basically a query within a query. This is usually done enclosed in brackets. There's also virtual views, which basically It's basically like a subquery, but it actually has a namespace, so it could be used like any other table. Like all these can be used as any kind of, wherever something named tables recorded in that cheat sheet, you could do any of these. Or it could even be, I could even refer to a table as a couple as joining several different tables into one table. Primary keys is basically a tuple of columns that uniquely define each row, and foreign keys is a tuple columns identifying the relationship to tables. So basically, okay, referring to this table. Important information. Some additional information is designed with a relational model in mind. If you want to later on get more into it, check out relational algebra. SQL is normalized. That basically means that that the tables are flat. There's no subtable. There's no subtables inside of a table. There's just a table. Like it cannot have in our tables. A good database is designed so that there's no redundancy in the data, so that each piece of data is only ever in one place at one time, unless it's a key. So that way, if you ever want to update it, update some piece of information, you go to that to that specific spot and look it up there. Otherwise, if you have several different areas, you can get nonconformity, and which is kind of a bad thing in a database. Relationships in SQL can be described as one-to-one relationships. Like for instance, a student has a mailing address, or one-to-many. The student takes many courses per term. Many-to-one relationship, like a course could have many students, or many-to-many. Students could have many courses, and each course could have many students. Yeah. So let's go into various statements. Select statement returns a row of values, returns a table of values. Sometimes it could be empty, as specified in the statement. So for instance, you select a list of columns from a table, and you could also specify where, like what kind of condition. There's also other clauses like I'm going to go into later on. If for list of columns, if we use star, it just basically says take all the columns from the table. We also use expressions and functions in the list of columns, returning values for each, getting a result for each row. And aggregate functions can take in many entries, most of the time grouped, and return a value per group. For instance, here with, let's say, for events, for Stats Club, name, start time, and location. Here's all the events for Stats Club. I'm going to try and get introduction to Hadoop done up and out before end of term. But cross my fingers. Our next talk is Prof Talk, which Einstein and Brownian motion, done by Matthew Scott. And yeah, and at the very last event, we're gonna have an end of term. Come out if you want to. Free food, that kind of stuff. Execution order for select statements. I find this really helpful for understanding a select statement. First, executed is a from clause. I have basically listed under in the cheat sheet. Like the first one should be describing like all the options for select statement. I printed off 30, but missed up. Apparently that wasn't enough, but this is wrong. I printed off double-sided, but like each side is exactly the same, so take whatever you want out of this.
You post this online?
What?
You post this online? The slides and the sheet.
Later on, yeah. Well, in Facebook. So like Stats Club Facebook account, and I'll put it up there. Yeah.
Well, it does even do your.
So. Yeah, I just laid it down there. Okay, going on. So from basically identifies what tables we're getting it from. This could also be subqueries, anything you. What I defined earlier as tables, views, result sets, whatever subqueries. That can put into the from clause, and from there, it brings to the on clause, which describes how to join tables up together. Then outer is executed. It's related to join, how to join up tables. Where is the filter clause? That's basically eliminates some rows from what you have so far. Group by basically groups the data by one or more attributes or columns. Then roll up basically, I'll show up that later on. Basically helps with aggregate functions. It basically for each level of a tuple in the group by clause, it does aggregations over those sets. Having clause is also another filter clause, but it's related to the group by clause. This way you could have aggregate functions in the filter clause. And the select statement, select what columns you want from that. Then distinct, basically for the implementation of SQL, basically it sorts out what you have so far, and then eliminates the non-distinct values. Eliminates everything but one distinct value for each row you have specified in the select statement. Then order the rows by ascending or descending value depending on the tuple, and then limit, which basically says I want the first 5 or want the first 500 of my rows. In the select clause, we could specify more than just columns. We could specify literals, strings, numbers, whatever, or we could do expressions, which is basically expressions of columns and literals. We could have functions, built-in functions, like for instance round. User-defined state functions. I won't be really going to that, but you could actually create your own function within SQL, and you could execute it wherever you want. For instance, here I'm selecting a string, a number. I created an example table with number of like 1, 3.14, and 8 point something, and this is basically all what's going to do with it. See, it goes up string, then my number. The num there is my original column that I have in my example table, and that's basically what it does up with it. Divide by 4, and then round off, or it could round off the number by 2 to do 2 decimal places. If we use distinct, basically gives only distinct values of that list of columns. As I said before, it could be table, join table, subquery, view, whatever. And I post. I'm basically using a example set from a book called Learning SQL by O'Reilly Media. This is basically most examples are taken from that. So I'm basically showing up the distinct values for within the example set. So it takes all the values, finds only distinct values, and returns them. We could also, to increase the reliability of SQL, we could also basically give aliases to the columns. For instance, here as for our for stats club, if I count club size as count stars club size from member, I get 29 people. I would like to more. Come sign up. Table aliases. We also could create aliases for tables. If, like for instance,
Why are you seeing the table?
What?
Why are you seeing the table?
Yeah, I did this up wrong, I think. But basically, if you want to single out various columns from specify from various, some tables have the same column name, so this is how to do it up. If you want to do a table alias, you basically do the same thing as like table, then as, and whatever you want to name it as. Like usually it's basically just a letter or whatever you want. I'll give you an idea. So select ename as name, position, description, exec as e. That as e, it basically says wherever that table is also called e. So if any reference to it, I could use it up. Use e dot whatever. Use e dot column whatever I want, and that wouldn't matter. And here I'm joining up a table on my position. This is for stats club stuff, and this is basically everybody's name, position, and basically the description of what they do. Could also briefly going through the types of statements you go to. Insert statement inserts a row entry into a table. So insert into table our variable, like our column names, and make sure it's in parentheses, and then we specify our values. It goes in the same order, so, and they have to be the same amount of values. So like it has to be the same order and same way. So the first column specifies the first variable. Second column name specifies the second variable. So the example set, we're adding an address, some states into the branch. So at row 9, we just shows it up there. And could also update it, update tables, set it value to wherever we want, to value, set variable to value, and our where condition basically says where we want it inserted, like for what rows. For instance, we change it up here, where branch equals 9, update the branch, and to change, let's just change the street address, and yeah, and just change it to a different street. And then, yeah, delete statements, we delete from table, and if you leave out the where clause there, it will delete everything from table. So give kind of a warning. You could potentially destroy a lot of stuff. Like for instance, my very first thing there, drop table. This delete doesn't really take away the table. It just takes all the entries of a table away. So you would lose all your information, but you still have the basic metadata for the table. That's it. But so just a warning from that. So if we delete that entry we just updated, as you can see, we basically just deleted that row. We can also create tables. So create table, variable name, then variable type, and then we can do some specifications, primary key, blah, blah, blah. Give you an idea. And describe, describe or DESC basically gives you meta information for a table. Remember, this has no data in it, so doing a select would return nothing. Alter statements, how to change characteristics of the table. Yeah, like one of the table I just created, I could change. I can add a column named major. Could also drop tables, drop indexes. Each version of SQL is slightly different, so that's the reason why I have that up there. Get an idea of how to drop. Like for instance, if you want to drop index, be different from in MySQL to database and to Oracle. And grants basically tells you what privileges as root, like administrative privileges. You can grant privileges to user accounts. This also would, if the account doesn't already exist, it will create the account. So, like for instance, grant privilege type, like could be select, drop, all those kind of statements. You put those in there, or all, if you want to give them all privileges to for a database to a certain person at a host. So grant all privileges to myself on my on localhost, and log into mine, and I get grants. I have a grant. Also could do the same, basically revoke it. So as a root, I go into it, revoke all my privileges from that, and yeah, no longer have it. There's three main data types in SQL: numeric, strings, and temporal. That's date, times, that kind of stuff. Yeah. So integers, there's basically various different types. You basically would like to get make sure that when you specify the int, the type of int you have, that it will cover all your cases. It's kind of difficult to change it out afterwards when you put it in. So yeah, each one has its own number of bytes it uses up and what ranges it go to. So, there's also a fixed point, which basically like for instance 2.003, that could be saved up as that point there, and it always records up to this point, and that's it. That's basically what fixed point is. It always keeping the decimal point at the exact same spot. You have precision and scale, which basically precision's how many significant digits, and scale how many digits after how many digits are after decimal. So this basically tells you, okay, for that there, like I have 2.003. I would have at least four significant digits, and 3 would be after. It would have 3 for its scale. For instance, if we want to take on values from negative 99.99 to 99.99, I would have decimal of 5 and comma 2. As I said before, it has a default of 10 and scale of 0 by default. Decimal, fixed, numeric, they're all same, numeric aliases for the same thing. For instance, also this is equivalent, so you could have without the brackets and having no specifiers, then it'll be automatically 10 and 0. This is usually the best data type for money and numeric values. Chars basically for strings of fixed length, and variable chars for variable length with the max length of as you specified. Usually 1 byte is 1 character. There's also bigger ones. This one's for MySQL, but each one has its own different size. This is all listed in the sheet there, so I'm not going too deep into it, but you basically get the idea. Any text larger than this will be truncated. Yeah, and it only uses the first ones for indexing. Temporal data goes into this format. It's always in year, month, day, and when time's involved, hour, minute, second. Date and time could also use fractional seconds too, for instance, that way. And also date time could also offer automatic initialization to current time and date and time. Yeah, stores with UTC storage for that way. Basically, you would get different times, accessing from different time zones. This way, that way, you don't have to worry about automatically converting. It just you set the time zone, and it does all up for you. This is useful, like it could be stamped in one area at one time, at one place, and you need conversion to another time for another area. Null values are the necessary evil of SQL. You have to be very wary of it. Basically, all the data types could have could be null values. You could enter null for it. It's never really equal to null, and it be best considered as unknown or missing data. Also, it interacts with other data types is interesting as well. For instance, x plus y, if x or y is null, you automatically get a null. Same thing for x greater than y, you automatically get a null. The test for null values is basically check for is null or is not null. SQL uses a 3-value logic system: true, false, null. For instance, null, it's the same thing for what we usually get for true, false. But when the null's involved, if it's and statement, it automatically changes the value to null, unless it's false, in which case it makes it false. And yeah, a bit different. It's best thought of null as I said, as unknown. So, like for instance, true and unknown. Oh, it's definitely true. And if it's false and null, you don't know, so it's null. And this makes a big difference because when you're doing aggregate functions and stuff like that, those functions don't really count in null. And joining things on nulls, you leave it out. So if you're not careful, you could very easily lose a lot of information. And also not in front of a predicate that returns a true statement, we'll just get false. Now, not false will return true, but not null will still return null because we don't know. Constraints, primary key. I already described primary key and foreign key, so we could also check constraints, enforce uniqueness on a field. specify that it's null, that a field could be not null. We also could drop constraints from tables. We also create indexes for fields, make them easily searchable. Yeah. Don't worry, just basically give the background, and then we're going to get more into it. There's two basically filter clauses in SQL: where and having. Where is before aggregation by the group by, and having is performed after, allowing aggregate functions to be used. There's an explicit group by statement in SQL. So if you use an aggregate function without the group by, it will return one row of that aggregate. For instance, it returns the where clauses basically filters result sets and takes away everything that's basically returns as false or null. And having clauses are very similar to where clauses, but can have aggregate functions in it. For instance, if we bring if we want to filter down the count of the title, let's so that it's greater than 3. What we had before, we could have the list of 7 titles we had before. Now it's down to just 2 rows, and we also have a count of that number of people in that table. Predicates, we could have various different checks, like equals, not equal, greater than, equal to, the usual. We also check if it's null, not null, or if it's between a certain range of values. This could be for anything, like this could be, that could be a date, that could use dates, numbers, even strings. In basically checks if it's in list of values. Those list of values could actually be a result of a subquery. Like, basically you could search for patterns and strings. Exists basically tells you if a return query is giving any results, and that's useful. Also, regular expressions, for instance, search through a column and find the group that's matches these regular expressions. Where clauses filters result set, removing rows, columns, rows from the ones. Okay, I already said this. Okay. So let's see here. Oh, any the equals to, not equal to, all those could also be used with the operators any or some or all. This basically says that that operation has to be true for either all these operations, or as true for any one of those operations. This way it could, for instance, any basically says that that operation has to return true for everything, or if you do all, it has to be true for at least one of the values. Group of filter conditions can be linked up together using and, or, and also parenthesize within in it to basically identify, do this precedent first, then return this one. This tells you, gives the order of precedence for everything. Say if we wanted to just in the example database, the tellers starting beyond 2003. Give a query like that. Group by clause groups up the data set by distinct values in the columns. So basically, we group up by the column values we want, the column tuple specified, and then so only columns specified in group by clause can be in the select statement, and there's already implicit group by if we don't have the group by clause there, returning just one row. So if we want to just get the total for available balance for like all of the customers in a bank, that would be, we just use the sum of all available balance, and there. To conceptualize the group by statement, you could think of the left-hand side as a table itself. Then it breaks the table down to certain categories specified in the group by clause, and then groups them up, and then we use aggregate functions on those to do it there. Like for instance, group 1 has 4 columns, 4 rows. 2 has 3 rows. Basically, get the idea, right? Any questions so far? Okay. Here's basically a list of aggregate functions. Average, we count them up. We count columns, or we can count, the whole count of the row. If we do column, if returns, if there's a null column, and you specify that it's a column, it won't count that. You also specify maximum value of the column you want, minimum value, min value. You can also have sum for numeric values of a column. The other ones are basically gives you population standard deviation. Below the double line, that's all for MySQL only. Various different versions of SQL would have pretty much the exact same thing, just names slightly different. Okay. Yeah, for instance, we want to find the number of customers by customer type and state. Do a count. Whisper. Want the available balance for each customer. No number of counts per customer, and that just, and also gives it available balance. If we use distinct, it would basically specify only count the distinct columns of this column. For instance, find the number of distinct titles an employee. 7, what we had before. Remember, we had 7 rows before. If we do roll up, this basically does aggregate up by each level. For instance, if we have 1 here, it will return a null value at the very bottom. As you can see, 4 plus what all of those up there will add up to 18, and that way it gives you levels of aggregation in one table. As for instance, we do up by title and year, we get a slightly different count, and it aggregates over the year, then aggregates over the title, and then finally for the whole thing at the very bottom. We can also join up tables. We could, there's multiple ways of doing this. For instance, first, we could cross join, which basically the Cartesian product of 2 tables. So each row would have all the entries for the other column for the other table. So like one row would have, like if we have n rows for one table and m rows for the other column, we would have the result set for a cross join would be n times m, which can make up quite a big table. It's not as useful as inner join, which basically joins up 2 tables on a join predicate, losing tables, losing rows when evaluated as false or null. There's also outer join, not quite as popular as inner join. which retains the record for each row, for tables, even if there's no matching rows on the other table. It can be specified left outer join, right outer join, and full outer join. Left basically says keep all the rows on the left-hand side. Right outer join says keep all the records for the right-hand table, the second table mentioned, and full basically says keep all rows for all tables. There's also natural join, basically it lets SQL decide where to join up things based off similar column names and types. It's not as recommended as inner join. Cross join, yes. So, for instance, this here, I made a table with T1 that has values 1, 2, and another one with 1, 2, 3. And as you can see, we have 2 times 3 equals 6 rows. Inner join is joining up 2 tables by a join condition. It's discarding when false or null. So yeah, so for instance here, joining up name, position for stats club and given description gives you all member stats club or positions and the description. The on clause specifies the join condition. The on clause can actually have multiple set of conditions connected by and or. There's also using. Using is basically same thing as on clause, but when the columns of 2 tables are exactly the same and have the same data type. Some implementations of SQL constructs an on clause from the where clause. DB2, this just basically makes it more optimal. Most things you could do with on clause, you could pretty much also do with where clause, but it will do a cross join, then you would drop a lot of entries, which makes it very inefficient. So that the on clause basically helps with processing your query. And for instance, yeah, what we're doing for, and if we use using instead of an on clause, gives us the exact same information. Natural join is lets the server decide on the join conditions. For instance, if we do the exact thing we're doing before, notice there's no on clause, exactly the same. Outer join, as I said, returns all rows for 1 or 2 tables, like for 1 or both tables, depending even when there's no corresponding value. There's the left outer join, right outer join, full outer join, and left outer join. Show you. As you can see, the left hand, the customer ID, basically retains all the rows, even when there's no corresponding value in the business table. And right outer join, if we do the exact same thing, but specify right outer join, now we eliminate all the null values, because it only returns the right hand number of rows when it's null value, so it'll just discard the other ones then. If we switch tables in our from clause and saying right and outer, we get the exact same table we had originally, because now the business table is on the left hand side and the customer is on the right hand side. And that's customer ID is the rightmost table, so it keeps all those rows. Yeah, full outer join. Unfortunately, it's not implemented in MySQL, which is basically what I was using. So, but if we do the exact same thing, we would basically get all values, all rows for both tables. Subqueries are contained in the contain the queries in itself. These are contained in the brackets. We can have non-correlated, which are independent of the larger query. Correlated queries, which is basically independent and basically are running concurrently with the outer query. The non-correlated query could be in the from, where, or having clause. For instance, for stats club exec, which club is in charge of posters, and if we basically select, if we basically get name position from exec, where quest ID is in the ones that's saying for poster, we get this guy here, which does up all the posters for us. With clause basically makes it look subquery look like a table in the executed statement, increase the reliability, but it's not really implemented in SQL. So, but yeah, it's actually really helpful. It basically the subquery name, you type in the name you want to describe it as, and then we can use it in the bigger statement specified below with the select ... Correlated queries makes reference to containing query it makes reference to the containing query, the outer query, and executing it only row by row. So, for instance, here we execute from there. We're using the customer table, and then basically finding out summing the available balance for that customer, and it's specifying account and customer, and then specifying, okay, this number has to be between those values. So that's bracket subquery there. You can see that it uses C dot, which actually refers to the outside the query, and A dot, which refers to account, which is inside the query, the subquery, and that's executed for every row. Then check from there, just checks between if it's these values, and as a result, subqueries can be used in the select as well as where and having clauses. For instance, if we didn't want to take away the rows, we just want to get like what that is. This is a way of doing it, and gives you all the values for each one. Brief description: correlated query is dependent on the outer query. Non-correlated is independent. Correlated is executed concurrently with the outer one, and in general, correlated queries take more time than non-correlated, and which takes more time than joins. So preferable to do up joins than non-correlated queries, and if you really need to, do correlated queries. Functions, there's various different functions in SQL. It would go too extensively, so I thought just put up some random ones. Current timestamp returns the time, current time of it being executed. Year returns a year for a date. Month, same thing for month. The day name tells you what day of the week it is, like Wednesday, Tuesday, Thursday, Friday. Floor is a number. Concatenate strings. Lower value. Log returns log. Current time returns the current time, and random number. Rand gives return random number. Now we'll be going into using SQL within R. I'm not sure how many people are here in stats, but this basically relates to stats. We need basically two packages, DBI, which is basically our database interface, and package specifying the unique implementation of SQL, for instance, for MySQL. And to give you an idea of how to do this up, DB driver just basically specifies what kind of procedures you would need to do to connect to a SQL server, even local one, and you just basically says, okay, specify the server, the driver by that there. Usually within the second package, you'd usually have something that just basically does it up itself too, that inherits from DB driver. DB connect to a database. Here I'm connecting to, this one here is connecting to myself. Connect basically gets a connection object specifying where I need to do things up. And you always want to disconnect after you no longer need to use it. So this is basically what that does. Disconnect. Query, send queries, sends a query. However, it does not retrieve it. That's done by fetch. DB get query actually gets, executes and retrieves information from a query. Fetch gets a record from a query. You could even specify like max number of rows to get back. List tables of and database connection. Get metadata from object. Read the number. Also directly read a table. And you also list the fields for it to investigate, what kind of information you would need from the table. This is actually executed in knit-r. This is our code right here, and as you can see, it specifies, okay, I'm using MySQL, and log into my own my own host, my own local server, to my own system, which basically specifies user Daryl using database bank, which is basically what the database in learning SQL refers to, and localhost, password, blah blah blah. Send the query of get the number from account, and then fetch it, then disconnect, and when we do ahead, just get the first couple entries of it. This is what results. If we want to connect to a remote server, this basically runs the same procedure, except for instead of host, localhost, we actually use a real host, and get a result. Here, just basically DB get query instead of the other one, and disconnect it, and we basically get find the number of rows for that table in that server. Thanks very much. The stuff that you use for this is learning SQL. There's also CS database course going on. Like usually, CS 338 is for CS minors. 348 CS is for CS majors. I'm listening on the current one by Grant Weldon. There's also Coursera courses, Introduction to Databases by Jennifer Woodham, and Getting Clean Data. That's basically, that there is more specific to R. And thanks very much. Thanks to all Stats Club members for helping put off this event, and Grant Weldon, which is letting me listen in on his CS 348 class. Some stuff not mentioned here is set operators, unions, intersections, case expressions, basically like if statements, views, transactions, relational algebra, which is kind of helpful for learning the relational model, how to set up a database, inserting data, and how to export data or import data, common separated values, XML values, Is there anything else? So that's all for. That's it. How do you guys like it? Thanks. Any questions? No? Yeah?
Where can we access this slideshow afterwards?
I'm gonna post it up on the Facebook, on our Facebook account. So just like Stats Club, UW Stats Club, and then just download from there. I'll be posting in the next few days. Yes?
Will there be any other learning program events like this?
I'm hoping to do up a Hadoop one. That's just generic. That'll be fairly introductory. But I'm planning on doing up a few more in the fall, and hopefully break this down into to 2 sections, into 2 parts, beginner and in a more advanced version, so that it'll be much more. We break down a lot more and get more into detail of like the stuff that I actually missed.